Hi everyone, I'm Evan and welcome to the Controlled Chaos Corner. In this video, it's going to be the first of a series of videos where we're going to be designing a 3D printed brushless DC motor. So designing brushless motors isn't that easy because the thing is, they heat up to a relatively high temperature and vibrations from imbalances in the motor can lead to rapid disassembly, and we definitely don't want that when we're designing 3D printed motors. Also, the plastic PLA can melt very easily, so we have to overcome that challenge by including active cooling systems, such as in this motor, there are little channels for air to flow down into the stator, and so that keeps it stay cool. Another thing to focus on is having to minimize the air gap between the rotor and the stator, because the larger the air gap, the more the magnetic flux is dissipated and the smaller the electric field, so less torque, and therefore it's going to be a much weaker motor. Also, winding the stator is kind of a challenge because the thing is, you have to either wind it with one single stranded wire or something called as Litz wire. It's when you bundle a bunch of copper wire together and you wind them almost as a bundle. So for this series, we're going to be winding our stators with Litz wire. Also, another important consideration for us is the motor magnets, because in this rotor and in all of this other ones, they're made with round neodymium magnets, and also the magnets are seated very deeply inside the rotor. So this increases the air gap. So for this motor, it's almost 3 millimeters, and that's like completely unacceptable. So remember, the larger the air gap, the worse the motor becomes. And these are round neodymium magnets. So you see the stator, it's a rectangle. It's not a rectangle, but it's like a rectangle from the side. And because the magnets are round, they don't take up as much area as they could be. Another thing is making sure the rotor interfaces properly with the bearings, because all of these motors have a rotor that just press fits into here. They just don't want to stay in as well anymore. So I have to find a way to make sure that the rotor stays in and doesn't want to come out of there, no matter how many times I take it in or out. So that's something we need to focus on for this series. Also, one other consideration is I have to figure out a way to make my own electric speed controllers, because purchasing them all the time is going to be quite expensive and prohibitive for a lot of people. And so being able to make your own speed controllers is going to open the doors to this hobby for a lot more people. Also, another side project that I want to do in this small series is making 3D printed propellers. I've tried this in the past. For example, these ones are 3D printed and they work surprisingly well. I just want to make them more refined and print better on most machines. Also, winding the stator, as mentioned previously, is going to be a bit of a challenge. I was thinking that it's better just to wind on the slots and then insert this kind of sleeve all over top of it, and then glue all that into place. Because what I think would make it better is that the sleeve is going to prevent all of the slots from moving around as well, because remember, the temperature, the PLA will soften, and so the sleeve will keep everything nice and together. So that's a bit of an overview of this project. All of the upcoming videos are just going to be designing, testing, implementing, improving things. For example, the next video is just going to be all about 3D modeling it and making it in Fusion 360 and optimizing it for 3D printing. And eventually, I think it'd be awesome to have a fully functional brushless DC motor. If that's something you're into, make sure to subscribe, and I'll see you in the next one. Bye guys.